going to learn a little bit more about loops in Java. What happens if you don't know exactly how many times you're going to require the loop to process? So far, we've been doing counter-controlled for loops. You know ahead of time. You're told print hello 10 times, find the primary numbers up to n, or print each odd number between 5 and 127. And we can control all of those loops with a count, and our author is calling them definite loops. I call them counter-controlled loops. Loops that are not controlled by a counter, our author is calling indefinite loops, and is very, very common not to know how many times you're going to loop. Maybe you can prompt the user, do you want to continue? And the user presses yes, and so you repeat the loop. You don't know ahead of time how many times the user is going to print yes to continue, or in this case, Q to quit. Let's look at this kind of loop. It's called an indefinite loop, and you cannot use the for loop for that. The for loop is only for counter loops, where this loop structure is called the while loop. Java has 3 looping statements: the while loop, the do while loop, and the for loop. Every program can actually be written with just the while loop. However, not every program can be written with just the for loop. So the while loop can incorporate counter-controlled loops. We use the for loop because it's easier for us coders to write. The while loop is a pre-test loop. Do you recall what test means? Here I have an example of the for loop that we've been using, and right here was our test, I less than 10. That's either true or false. So a test is something that's true or false. You can see this in the flow chart. Pre-test means that you're going to start the loop, and the first thing you're going to do in the loop before you execute the body loop is a Boolean expression that will be true or false. If that Boolean expression is true, you enter the loop. When you're done with the loop, it comes back up and it tests again. And it'll test again, just like the for loop continued until this test was false and I was 10 or greater. Here's another way to view it. You can see that you're going to begin your loop with a Boolean expression, and this Boolean expression is exactly the same as the condition that you put in the if statement. Anything that can be evaluated for true or false. As long as it's true, the statements will execute. As soon as it becomes false, you will continue with the logic in the rest of your program. Let's look at the do while loop. The do while loop is a lot like the while loop. However, it is a post-test loop. The condition is not tested till the end of the loop. You will always begin right with the first statement and all of the statements in the loop. Then the decision's made here. What value is this Boolean expression? Is it true or false? If it's true, we loop again. Why would you want to have a post-test loop? Well, sometimes you don't know the value of your Boolean expression. It's not set until sometime in the loop. So in those cases, you may want to do a post-test loop. Here is the Java syntax for a while statement. You're going to begin with the keyword while. Like an if statement, you'll have parentheses with one condition in it. Unlike the for, it had 3 parts to it. The while will have one Boolean expression, and then you'll have your brackets and with the statements that you want to execute inside the loop, inside those brackets. Let's talk about the loop control variable. In this for loop, I is the loop control variable. The first time the for loop executes, I is declared and set to initial value. In this while loop, employees processed is our loop control variable. Here it is not initialized or declared. So one rule about creating a while loop is prior to the while, you have to declare employees processed and initialize it. So you might just want to say, similar to what you have here, int employees processed equals 0, but that's going to be a statement prior to the while. Then we had our test in the for loop. That's the second part. And 2, the second part is the condition. And here's our test. Your condition will go inside of parentheses right next to the keyword while. Finally, the last step we had in the for loop was somehow we had to modify I. Notice that our loop control variable is in all 3 parts of our loop, whether it's a for loop or whether it's a while loop. This means somewhere in here, we need to make sure employees processed, which is our loop control variable here, gets modified. If you do not modify, you have the dreaded infinite loop. And that dreaded infinite loop means that your user is going to be stuck seeing a little spinning symbol that never gets done. The only way to get out is to maybe go to the task manager to exit or to reboot your computer, which can be very frustrating for your users. You want to always make sure to test that you've set up that you're modifying your loop control variable inside the loop. The textbook gives a good example of a loop where you can't use a counter. So you must use a while or a do while. And that is to find the smallest divisor of a number. To do that, you're going to loop through sequentially the numbers, smallest to largest. And if you recall, a value is a divisor if the remainder is 0. If you also recall the modulus operator, if the result of the modulus operator is 0, then that number is divisible. Think about why you can't use a counter here. Let's say our number is going to be 4,750,000. And you think, wow, we're going to have to loop a lot of times. No, you don't. That's an even number. It doesn't matter how big that number is. An even number always has the smallest divisor of 2. You only loop through that one time. But you might have a prime number that is huge. In that case, you are going to loop all the way through as a prime number until you get to it. So I'm in NetBeans, and I'm going to create a method called smallest divisor. And I'm going to change this return in a minute, but it's going to return an int, and it's going to take as a parameter variable the value n that we're trying to find the smallest divisor for. So I mentioned that you need to initialize your loop control variable. Let's call this loop control variable possible divisor. And we need to initialize possible divisor before we get to the while statement. That was one of the 3 things you need to do. In this case, possible divisor will start at 2. We're going to assume 2 is it. And if it's not, we're going to go on to 3, and then we're going to go on to 4. The next thing we have to develop is our test. And our test is it's going to keep looping as long as possible divisor is not a divisor of n. So n is provided here as a parameter variable, and we're going to take the modulus of n by the possible divisor. If that value is not equal to 0, then we need to continue to loop. As soon as the value equals 0, we exit the loop. So as long as it is not equal to 0, we're looping. Inside of the loop, not much that we actually need to do. If it's not 2, we're moving on to 3. And if it's not 3, we're moving on to 4. So inside the loop, all we're doing is making sure that we modify our loop control variable by adding 1. What happens when you exit the loop? You can return possible divisor. Let's test this. Let's say we're going to call smallest divisor, sending 5 to it for n. Inside this loop, we'll be testing is 5 mod 2 the first time. 5 mod 2 is 1. And so 1's not equal to 0 is a true statement. We come in, possible divisor becomes 3. Come in again, 5 mod 3 will be 2, and 2 is not equal to 0 is true, and we come in again. Possible divisor becomes 4. 5 mod 4, we have a 1, and again, 1's not equal to 0. This becomes a 5, and we'll loop back up. 5 mod 5, that's 0. And whenever you're going to have a prime, you're going to see that possible divisor will be equal to whatever the value of n is. But that is 0. That's a true statement. Now, what did we say possible divisor was? 5, and we're going to return that 5. Up in main, I've added a few calls to our smallest divisor method. Just going to output the value. 2, since 8 is even, 2 will be the smallest divisor for 8. 7 must be going into 413. And 5 is the smallest divisor, obviously, for 715. I didn't even need the computer program to tell me that. Let's compare the pre-test while loop with the post-test do while loop. Here's the syntax. With the pre-test, you have the while and the condition is immediate. And there's your braces for your while block. With the do while loop, which is a post-test loop, you'll notice you still have a while and condition. It simply goes after that block, and you do need to begin with the keyword do. Here are 2 examples of printing out numbers from 1 to 10. You will see that they're very similar, initializing the loop control variable. Here's the test, it's just here at the bottom, exact same statements. Usually I am going to use a while myself, but there may be conditions where you don't know the value until you're in the loop. And I've got a guessing game as an example. You can read through that, but input validation is a very good example. You can do any coding with just a while loop, but look at the difference in the structure of these loops for input validation. It looks like the while loop's a little bit more work. With the while loop, you're going to get the input prior to the condition because the condition depends on having that input. You're testing that input. So I'm expecting here a number to be entered because we have the next int. I'm sorry, that should be a lowercase n. So I'm expecting a positive number to be entered, and it's being assigned to value. The condition tests if that's not true. Here, is value less than or equal to 0? I want more than 0. And then we're going to prompt. That's not correct. Input it again. But you notice with a do while loop, I don't have this statement twice. You need that statement twice for it to work with a while loop. It's called a priming read, but you only need it once with a do while loop. So with input validation, you may want to use a post-test loop. The next video is over validation and verification for more coverage of these important topics.